Morena tātou, or kia ora, whatever time of the day it is for you watching this. In this video we're going to go over the 2019 exam question 2. So here's the first question from question 2. We've got this molecule here, which is propene, and we will answer the first part of it. We're going into compound A. So we've got a polymerization reaction. So what is going to be the product of a polymerization reaction of propene? So the easiest way to work out the products of a polymerization reaction is when we just change the way that we draw the structure. So instead of drawing it like that, we can draw the monomer, and we draw the monomer showing the centering around the double bond, and then we just show as groups coming off each carbon what the atoms or the groups are. So here we've got carbon going into 3 hydrogens from each one, and then we've got a methyl group off that one. And so now to turn this into a polymer, we just need to break that double bond, turn that into a single bond, and then add more single bonds to it, and then we could continue on adding more repeating units. So to show this as a polymer, we will just draw a bracket around it, and a bracket around this, and then we put N there. So that shows that this can happen however many times. That N could be 100, who knows. So we just put that into this box there, and the name of this. So we need to take this name, which is propene, and we just add poly to the start of it. So the name of this polymer is going to be polypropene. Nice. So this one here, we've got 2 reactions. So if we add dilute acid to propene, what are we going to get? And then how can we get from that, whatever our product is, back to propene with another reagent? So I'll draw out the propene molecule. Sorry, I'll just get rid of this to make it a bit tidier. So we've got CH3, and then a single bond, and then a double bond with HH. And this dilute acid is going to add a water molecule to this propene molecule. So we've got H2O. So we're going to have the OH going into one of the carbons, and we're going to have the hydrogen going into the other carbon. So you'll notice that this here says it can be a major or minor product that we're talking about. So it doesn't matter which one we put in. So there would be 2 possibilities. We could have the OH going into that carbon, or the OH going into that carbon, and then the hydrogen would have to go into the other carbon. So let's draw the major product just because, as good practice. So the major product is going to be the one that the hydrogen bonds to the carbon with the most hydrogens already. So that's going to be this one here. So we need to, it's an addition reaction, which means we break the bond, and then we're going to have a hydrogen now bonding to that carbon, and a hydroxide group bonding to that carbon. So we can draw that in here, 2, 3, H, OH, and then all the rest of the H's. And then to get back the opposite direction, this is an elimination reaction, so it's just memorizing. We need to know that concentrated H2SO4 will take us from an alcohol into an alkene. So then this reaction, we've got hydrogen bromide added to an alkene. The hydrogen can go into one of the carbon atoms, and the bromine will go into the other one from the double bond. So let's use our drawing here again, and it's going to be the same theory as what we had before, where the hydrogen is going to be bonded to the carbon with the most hydrogen atoms already. So the major product is going to be where we get the hydrogen. So we've got HBr. So the hydrogen will go into that one as the major product, and then the bromine will have to go into this carbon, Br. So our answer there is going to be CCC, Br, H. Just quickly filling it in. And then we just do it the opposite way around. That to there, that to there, to get the minor product. So C, BRHH. Nearly there. Oh, messy as. And then the next thing is that we need to know how we get from this 1-bromo-propane into an amine group. An amine. So we need to use NH3 alcoholic. Alcoholic ammonia will get us from a haloalkane to an amine. So you can see it's lots of memorizing. There will always be a question like this where you need to finish a reaction scheme. Very satisfying once you get it, but yeah, just takes some time, takes some practice. So yeah, just keep working at it. Okay, the next one. So explain how you identified the major and minor products in the reaction of propene with hydrogen bromide. So that is putting into words what we were explaining with this hydrogen going to the carbon with the most hydrogens already. So that one, when that gains a hydrogen, that is the major product. So we need to explain that, which is can make it a little bit trickier. So to start off with, to get some quick marks, we can describe what type of reaction that is that we're talking about. So we would say this is an addition reaction. It's an addition, A-D-T-I-O-N, and we would say that this is an unsymmetric alkene or an asymmetric alkene. And so what I mean by that is if we had ethene, which is symmetrical, both of the carbons in the double bond both have two hydrogens bonded to them, so there wouldn't be any preference for the hydrogen to go onto either of them. So we wouldn't have a major or minor product in that case. So we need to outline that we've got an addition reaction of an asymmetric alkene to start with. And then we need to just describe the rich get richer rule as best we can, using, I guess, explanation terms. So we're going to say that the hydrogen will go to the carbon with the most hydrogens already. So in this case, it's the first carbon of the double bond. That will be the major. And then we would say as the minor, the hydrogen would go to the carbon with the least hydrogens, which is the second carbon. The second. Okay, and just tying that all together as best you can. Practice writing your answer and then check the marking schedule to see what the actual suggested answer is, and then see what changes you would need to make to get an excellence. Yeah, just doing the best you can as well with that, a bit more practice. And then compare and contrast the reaction that forms compound B to the reverse reaction that forms propane. So in this one we had a propane molecule, and that went into an alcohol, like this. So let's say we had the OH going there. So for this one we had H2O dilute acid, and this one we had concentrated H2SO4. Why do I keep putting an S instead of a 2? I don't know. H2SO4. So this one is we're adding, to go in this direction, we're adding atoms or groups of atoms to those carbons, and in this direction we are eliminating the hydroxy group and the hydrogen. So we'd start off by saying that. We'd say in one direction, going down that way, it is addition. Then in the opposite direction, it's elimination. And so let's just talk about where the atoms go. So in this case, we've got a hydrogen and OH group being added to each carbon in the double bond. this requires dilute sulfuric acid, dilute H2SO4. Trying to do it again. And then in the opposite direction, it is elimination. So the hydroxyl group and the hydrogen are eliminated to form a water molecule and then form a double bond, and that requires concentrated sulfuric acid. And yeah, that's about all you can write. It's just the compare and contrast question. Let's have a quick look and see how we've gone with that. So the reaction is an addition reaction where the double bond is broken. The reverse reaction is the removal of the hydrogen to form a double bond, forming the unsaturated molecule with a double bond. The elimination reaction uses concentrated sulfuric acid to remove the water. The addition reaction uses dilute sulfuric acid. So you're really just stating what you know, and then the reactions are opposite. So I guess this is the final compare and contrast explanation part of it. So you're saying that you know that they're opposite. One breaks the double bond, one forms a double bond, and then you're done. Yeah, so that's question 2. In the next video we'll go over question 3. Thank you.